Hello, ladies and gentlemen. Today we're going to talk about proving again, but today we're going to talk about proving other things, not just proving triangles congruent, but more than that. So we need to make sure we have our foldable and something to write with. All right, so if we look at this proof, number 11 from our proof packet, it's already done or should already be done. We're looking now that if I'm given A, B, and BD, AB and BD are congruent and BC and BE are congruent, I need to prove triangle ABE congruent to triangle DBC. Now, we've probably already done this and already know how to do this, but now instead we are going to cross out what we're trying to prove, and we're going to take this one step further and try and prove angle A congruent to angle D. So we're still going to have to prove the triangle is congruent, but from there we're going to try and figure out new information. So we have to go forward and see how we might do this. So if triangles are congruent, then what happens? Well, let's think about that. If we know that triangle ABC is congruent to triangle EDF, if I were to write that out, triangle ABC congruent to triangle EDF, again, when I write out that congruency statement, know that we would know that angle A is congruent to angle E, B is congruent to angle D, and C is congruent to angle F. So if we know that triangles are congruent, we know that the corresponding parts of the congruent triangles are therefore congruent. So when we look at this CPCTC, this is what we are going to use as we try and prove new things congruent today. So remember CPCTC, make sure you get that written down, and those letters, that acronym comes from corresponding parts of congruent triangles are congruent. So when I ask the question, is angle B congruent to angle D? Well, yeah, if I know the two triangles are congruent. I can assume that B is congruent to angle D. So again, we want to make sure you get that written down, CPCTC, and that's what we're going to use as we move forward in today's proving. All right, so our goal here is to prove that side BC is congruent to side AD. Now again, these proofs are a little bit different. We're still going to want to prove the triangle is congruent because by CPCTC, if I know the triangles are congruent, then I can figure out that corresponding parts would also be congruent. So our first step would be to prove that triangle ABC is congruent to triangle CDA. So we're going to try and prove that first and then see if I can prove BC is congruent to AD. So it looks like they've already given me what's given in this information. So I'm just jotting down what's already been marked. Okay, so we know that side AB is congruent to CD, and we know that angle BAC is congruent to DCA. Okay, so then our next step, if I were to deduce any information out of this picture, I could say that AC is congruent to AC. So if I were to look here, can I prove these triangles congruent? I would be able to by SAS. So when I go forward now, I got to make sure I write everything down in my proof. So the first thing I want to write down is that marking I made. So 3, I would want to say that AC is congruent to AC. And my reason for this would be the reflexive property, because I know that AC is congruent to itself. And after I show that, it looks like I have a side here, I have an angle here, and I have a side here. So I have my SAS in my proof. My fourth step then could be to prove the triangle is congruent. So triangle ABC congruent to triangle CDA. And again, this would be by SAS. But notice I'm not trying to prove the triangle is congruent. I'm trying to prove that BC is congruent to AD. Now, if I look at this statement, can I say that BC is congruent to AD? It looks like I can. I can prove that because they would be corresponding parts on these triangles. So if you look at BC here and AD, those would be the same parts of those triangles. If I were to turn this bottom triangle upside down, it would land right on top, and AD and BC would be right on top of each other. So the reason I can say that they are congruent, now that I've proven my triangles are congruent by SAS, I can say that BC is congruent to AD simply by the fact that they're corresponding parts, so by CPCTC. So strictly because they are corresponding parts of my triangles, I can say that they're congruent because I proved the triangles themselves are congruent. All right, so let's prove another one here. Again, what I'm trying to prove is that angle A is congruent to angle C. So in order to do this, again, since I have triangles, we're still going to want to try and prove the triangle is congruent to start with. After I prove them congruent, then I can use my CPCTC to help me prove that other information as long as they're corresponding parts. So again, the first thing we're going to want to prove is that triangle ABD is congruent to triangle CDB. Excuse me. Okay, so then first thing I'm going to do then, notice I already have two sides, and the other thing I can deduce from this information is that BD is congruent to BD. Now when I look at these two triangles, how could I maybe prove them congruent? We know by using our postulates that we could use SSS to help us prove these triangles congruent. Now notice I have here already in my proof that the given information is written down. So since they already marked two sides for me, I wrote both those sides in my proof and I can mark them as given because they were already marked on my picture. So from there then it looks like I have to include one more side. I've already used two. I've already written down two in my proof. So this third one would be that BD is congruent to BD. I'm writing in what I marked on my picture. I was able to deduce this information, so I'm going to write it in my proof. And again, since it's the same line, this would be our reflexive property. So now that I've written that down, I have all three S's written in my proof. My fourth step would be to prove that the two triangles are congruent. So triangle ABD is congruent to triangle CDB. And again, my reason for this, using our postulates or our theorems, congruence theorems, would be SSS. So now that I've proven that both my triangles are congruent, since I know the triangles are congruent, I know that their corresponding parts have to be congruent. So notice here that A comes as the same time as C. So since I've proven that those two triangles are congruent, I can deduce the information in number 5 that angle A is congruent to angle C. And the reason again that I know this is that after I've proven my triangle is congruent, now I know that their corresponding parts have to be congruent. So this would be CPCTC. And again, we want to finish with our box. So since I've proven the triangles are congruent, then I can say that their corresponding parts are also congruent by CPCTC. All right, so again, we have example 3 here, and we're trying to prove that angle A is congruent to angle C. So notice again my picture, I have triangles, so before I can prove that those angles are congruent, I'm going to want to prove that the triangles are congruent. So I'm going to try and prove that triangle DB is congruent to triangle CBD. And I want to try and do that before I can prove that angle A is congruent to angle C. So notice here, if I look back in my proof, again, I've already written down the given information, but is there any other information I can deduce? Because in order to prove the triangle is congruent, I have to have at least 3 things. So notice that BD is shared by both triangles, so I can mark BD congruent to itself. So let's see if I can prove these triangles congruent. Well, it looks like I have side, side, angle. Side, side, angle. If you notice, if I were to read that backwards, that would say a bad word. So if I read it backwards, I know that I can't have congruence here, but this is a special case of SSA because it has a right angle. And whenever I have a right angle, I want to check for HL. So notice that HL, I have to have hypotenuse and a leg, and it looks like I do have an hypotenuse and a leg congruent to each other. So in this instance, I'm going to use HL to prove these triangles congruent. So if I go over here and I start my proof again, I have to list my given. So I have an S here and an A here. So it looks like I have to get that last S, or that last S, because again, we want to do HL. So I've already talked about this angle here. I've done my hypotenuse. This would be my hypotenuse, my special case. This would be my right angle that I need to have. Now I have to include this other angle. And so this other marking I made, 3, saying BD is congruent to BD. Again, I know this because BD is the same line, so that would be my reflexive property. So lastly, so since now I included my L, since I have HL, I've done that all in my proof here. I've shown that I have a hypotenuse congruent, a right angle, and I have a leg congruent. Now I can prove my triangles are congruent. So step number 4 would be that triangle ADB is congruent to triangle CBD. D. And again, my reason for this would be the congruence theorem HL. So now again, since I proved that my triangles are congruent, I've proved they're congruent by HL. Now that I know that my triangles are congruent, can I use CPCTC to say that angle A is congruent to angle C? Again, if we look at my statement here, angle A and angle C, they happen at the same time, so it does look like I can use that because they are corresponding parts of those triangles. So angle A is congruent to angle C, and again, my reason would be CPCTC. So if you have any questions, make sure you're jotting these down so we can revisit them. All right, so our last example of the day, we want to prove that M is the midpoint of JL. So first off, what does it mean to be the midpoint? Well, midpoint just means in the middle. So if it was in the middle, we could assume that JM would be congruent to LM. That's what it would mean for M to be in the middle. So if I can somehow prove that JM is congruent to LM, I could prove that M is the midpoint. Well, even before that, I need to look at this picture, and what am I given? Well, I'm given that I have two triangles here. So before I can prove that these two are congruent, I would want to prove that triangle KJM is congruent to triangle KLM. So if I can prove that, then I can prove that side JM is congruent to LM, which would then mean M is the midpoint. So we kind of have a lot to do in this example, but let's see if we can do it. Again, I think we're getting good at proving triangles congruent. So our first thing here is we're going to want to prove that those two triangles are congruent. So if we look at this picture, is there any information that I can deduce again? Well, I can say that KM is congruent to itself. So right off the bat, we're given that JK is congruent to KL, but we're also given that the angle KMJ is congruent to KML. So we know already two things. So I know that I have those two things, and then I can mark that KM is congruent to itself. So if I look at this picture, again, it looks like SSA, but since I have a right angle, it's a special case. So do I have hypotenuse leg? It looks like I do. So we want to try and prove by HL. So again, we have that our hypotenuse is already congruent. We have my right angle. Now I need to prove a leg. So how do I figure out that leg? Well, it looks like the leg of these ones is our KM, and we knew that KM was congruent to KM because anything's congruent to itself. So again, that reason for us would be the reflexive property. So after I show that the KM is congruent to KM, then I have my HL. So now I can show that those two triangles are congruent. So triangle KJM is congruent to triangle KLM. And my reason for this would be our HL postulate. And so now that I know that those triangles are congruent, can I say that JM is congruent to LM? Can I say that this side here is congruent to this side here? I can do so because they are corresponding parts of my triangle. And we know that corresponding parts of congruent triangles are congruent. So I can say that JM is congruent to LM because they're corresponding parts. So that would be my CPCTC. So then lastly, we are trying to prove that M is the midpoint of JL. So do I have enough information to say that M is the midpoint of JL? Well, definition of midpoint means that M has to be in the middle, and if it's in the middle, then JM would be congruent to LM, so it looks like I have, and my reason for this would be the definition of midpoint. So I was able to show that using CPCTC, but then also knowing my definition of midpoint, so therefore M has to be the midpoint of JL. And this would conclude my proof, so I'd have to include my box. So again, this might be a little bit confusing. Example 4 is probably the most confusing one of the 4 we did today. So if you have any questions, make sure you jot them down so we can address them when I see you. So I want to thank you for taking good notes, and I'll see you when I see you.